Okay, so it's 3-2. It is linear functions. Sorry, I almost read tomorrow's. So we are not going to have homework over this tonight because I want us to finish a certain amount before Thanksgiving, so we're going to go ahead and start a new lesson tomorrow. But it's 3-2, linear functions. So the first thing I want you to write down, we're not going to read that paragraph because it seems very confusing, is this. Write that y equals mx plus b. You've seen this before, but we're going to talk about it. So it doesn't even tell us what that form is called. It just says equations can be written in this form, but we're going to go ahead and label it with what it actually is. That is called slope-intercept form. I'll get the door in a second. Yes, ma'am. Okay, so that is slope-intercept form. Now we're going to talk about what that means. So y and x will not change. Those are part of the equation. So the only things that are actually really numbers are m and b. M represents your slope or your constant. B is called your y-intercept. Y-intercept, excuse me, is on the y-axis. That's actually a point where your x is always 0 and y is some number, but it's on the y-axis. Okay, so we will be looking at that form. What we're mainly talking about today is linear versus nonlinear. So everything we're looking at is a function. Okay, so you know Thursday and Friday we were determining is it a function, is it not. Everything we look at today will be a function. But it's linear versus nonlinear. When you hear the word linear, what do you think that means?
Line.
Yeah, it has the word in it, line. Linear means it makes a straight line. Nonlinear, it's not a straight line. It's as simple as that. So the first part, if you look, you don't have to draw these. I just am because I can't get it to go up there. On these graphs, we're just having to determine right now, is it linear or nonlinear? Would that be linear or nonlinear? That would be nonlinear. That is not a straight line. What we know it's a function, it's just a nonlinear function because we could do the vertical line test and see that it is a function. And then on B, we have this, linear or nonlinear? Yeah, that would be linear. It is a straight line. Linear has the word line in it. It means straight line. Okay, so then we could look at a table. We can tell from a table whether it is linear or nonlinear. So what we have to do is we have to see if there is a pattern that repeats or if we can get a constant. So let me write. You can go ahead and write that first table down with me so you have one example of what it means. So we have, and any table that's written sideways like that, X is always on top, even if they don't tell you that. Y is always on bottom. So we have 3 over 36, 6 over 30, 9 over 24, and 12 over 18. Okay, so what you're looking for is a pattern that is happening. So just looking at your x's, what happens from here to here? Either plus 3 or times 2, we don't know yet. So then you look here, from here to here, is it plus 3? And then here. So we got plus 3 every time on the x. Now let's look at the y. From 36 to 30, what happens? Minus 6. That's still okay, because from here to here, what do we have? And then last one. So since the same thing was happening, it didn't have to be plus 3 everywhere, but the same thing on the x is happening and the same thing on the y is happening. That means it is linear. Okay, if that just means these are actual points, like that's actually a coordinate, if I were to go graph them, we know it would make a straight line because it has a pattern. Does that kind of make sense? We don't have to actually graph it though. We just found that there's a pattern, which means it will make a straight line, so that would be linear. Okay, and then B, you don't have to write B down. 1, 3, 5, 7. Okay, on B, what is happening on top?
1, 2.
Plus 2. Is it still happening? So far so good. And then when we look on bottom from 2 to 9, what is that?
7.
Plus 7. 9 to 20? Plus 11. And 20 to 35. So is that linear or non-linear? Non-linear. It just means it will not make a straight line. Could still be a line, just not a straight one.
Could be like a boomerang.
Okay, so copy these 4 problems down. You don't have to have your graphs exact, just mainly draw the line on them. And you're going to answer linear or non-linear. So pause the video and try those, and then I'll go over them with you. Okay, so on these 4, on number 1, is that linear or non-linear? Linear, it's a straight line. The pictures are pretty obvious. Number 2, non-linear. The only ones you actually had to calculate something were on 3 and 4. So on 3, what pattern do we have?
Plus 1.
So it's the same on all of them. And then what about on bottom?
Plus 2.
So is that one linear or non-linear?
Linear. It's a line.
Okay, and then on 4.
Plus 1. Here's one that kind of got me a bit.
Okay, because why?
Divide by 2.
Because you could divide by 2, correct?
Yeah.
If you divided, did you get the same thing each time?
Yeah.
Yeah. So it's still linear.
I just didn't know if you could divide.
Right. You can multiply, divide, add, or subtract.
Wait, I actually wrote 3.
First I tried that.
To subtract.
Now I figured it was.
Yeah, so when you subtracted, it would have been 8, 4, 2. You would kind of see that there was a pattern. Maybe that would help you go back and see that you could just be dividing each time.
I subtracted first.
Good.
Alright.
Okay, so now what we're going to look at, example 3. This kind of starts to get not as simple, but it's not as scary as it looks. Let me just say that, because it looks terrifying, but it's not, I promise. It's not easy, but it's not terrifying.
I looked at the question on Mars.
So what I want you to do, they list out 6 different equations. Go ahead and write those down, but I would write them up and down because we're going to write stuff out beside each one. Just those equations. So we have y equals 3.8.
Y is square root of x.
Y equals the square root of x.
Y is 3.
Y equals 3 to the x power.
Y is...
Y equals 2 over x. Y equals 6 times x minus 1. And then y equals 0. Is that right? No, x squared minus y equals 0.
X.
So write those 6 down. Let me skip back over so you can see those.
It's basically the same problem, but from like 50 different dimensions.
Okay, so what the instructions say is which of the following equations represent linear functions and explain. So these are where we're going back and we're looking at that y equals mx plus b form. It's where we're kind of trying to base it on that. So how we can determine is if they are functions is if we can kind of rearrange them to rewrite them in that form. Now, which ones were the only ones I said actually represent numbers?
M and B.
M and B. Y and X are there. So whenever I look at this, do I have an X?
No.
So far, no. Do I have just a plain number by itself? Yes. On this side, 3.8. Do you see how this plus B is over by itself?
Yeah.
Okay, so I actually could write this one if I did this. 0x, because 0 times anything is what?
0.
So that would technically cancel my x, and I would just be left with 3.8. But that just goes to show it could be written in that form if it had been a 0. Okay, so that one, we're going to put a check by. It is linear. So if you're confused, it's okay. Do it.
How do you know if it's linear?
If we can put it in this form. Okay, if you're still confused, it's okay. Let's go through some more of them. I know that sounded weird. But like this one, square root of x. Is there any way that I can rewrite this to have a number times x?
Yeah.
Well, 0 times x would cancel. Let me reword that because that sounded confusing for me. Square root. That is going to give me a graph that's not straight. What's one thing we talked about last week that I told you would make a graph like this?
Divide.
Negative numbers. No.
No, if it went like this, what did it have in it?
Real numbers.
It had an x squared. Okay, so we already know if it has an exponent, it's not going to be linear. Well, square root is the exact opposite of x squared. So if x squared looks like this, the square root of x actually looks like this. So it is not linear. There's no way I can make that linear, so you can put an x by it.
Wait, that makes another problem.
Yeah, it kind of looks like...
Square root of x times x.
Okay, so then y equals 3 to the x power. Would that be a straight line? No.
No. 3x to...
So even though that first one was kind of confusing, is it making a little more sense?
Yeah.
Basically, if it's kind of weird or out there, it's non-linear.
I'm still...
It's okay. We're not done. Okay, y equals 2 over x. So now, we can have fractions, but we have x on bottom here. That actually means something. Because if I were to rewrite that where x was not on bottom, it would be 2 times x to the negative first power. That means the same thing. Again, what did we say about exponents? It's not going to be linear. 2 over x is not a straight line. So that is non-linear. Okay, this one, y equals 6 times x minus 1. Well, before we can figure it out, we need to get rid of these parentheses. How could I get rid of those? We can't just drop them. Distribute the 6. So 6 times x is 6x minus 6 times 1 is 6. Now, does that look pretty close to that form?
Almost exact.
Almost exact. Because even though it says minus instead of plus, it's still in that form. That'd be the same thing as saying mx plus b, just the b is a negative 6. It still can be in that form. So this is linear.
So you don't have to solve anything. You could, well, yeah, but not.
Yes.
Okay.
Yeah. And then the last one, it has an exponent. So is it going to be linear? No.
No, because it has 0.
So right now we're still just determining if stuff is linear or nonlinear. Okay? So, try 5, 6, and 7. You're trying to get them in the form y equals mx plus b and tell me if they're linear or nonlinear. Okay, 5, 6, and 7. On 5, we have y equals x plus 9. Is that linear or nonlinear?
I believe that is linear.
Okay, so what would my m be in this problem? X is x. Okay, well, 0 times x would have canceled out the x. So what technically would be there to keep an x? A 1. So your m here would be 1. But yes, it's linear. We don't have to do anything. I was just showing you that it's not 0. If it was 0, they would have written it y equals 9, which is still a function because then we could have 0 times x. I was just showing y'all that. Okay, on 6. Okay, so they kind of tried to trick you with this one. X is on top, it's not on bottom, correct? Mm-hmm. So that is the same thing, 3 times x over 5, as saying 3 over 5 times x. This is linear because that's mx plus b could be 0.
Okay, I got that.
So that one is linear. And then on 7, y equals 5 minus 2x squared. There's an exponent, so no. So 5 and 6 were linear, 7 was non-linear. Okay, so looking up there now, this is just different ways that we've seen functions so far. So now we can use a table to determine. Remember those little bubbles, how we determine, and then we can look at a graph.
Yeah.
The graph is
Yes, it is. Okay, now we got to talk about some new words. Discrete and continuous. So go ahead and write those two down. You might leave yourself a little space because we're going to draw some number lines with each one.
Do we put domain there or?
Yes, so when we are talking about discrete and continuous, we're only talking about your domain, which is which values?
X,
Your
which is
X.
left and the right.
Okay, so your domain values, your X, we're going to have discrete and continuous. Okay, so when you hear the word discrete, if I said, hey guys, y'all don't have any homework today, but be pretty discreet about it. Well,
make it a secret.
yeah, kind of make it a secret. Don't make a big deal out of it. Keep it kind of simple. So discrete in math, or referring to your domain, means it's pretty limited. Okay, you're kind of keeping it simple, if that makes sense. So they tell us that it's a set of input values that consist of only certain numbers in an interval. So they're talking about, so your X values, your input values, are limited to certain numbers. So I'm just going to kind of summarize by saying the word limited to kind of help you. You might put it's limited. And then draw that number line that they reference, because they went ahead and made it nice and used the same numbers on both to kind of show you the difference. And it has points at 1, 2, 3, 4, 5. And it tells us, okay, so it would be the integers from 1 to 5. So your discrete domain would be 1, 2, 3, 4, 5. So then when we get to continuous, it just means everything in between there. Okay, so if you want to say the word unlimited, you could, or just we know if a line is continuous, it doesn't just stop and skip a number and keep going. It means it's solid the whole way, everything in between. So then draw that number line. Same number line. And it would be all numbers from 1 to 5. And I'm going to explain the difference.
It's the and thing.
Kind of. It does look like an and. Yes, I see what you're saying on your graph. So let me stand over here so they can see that.
It might not be a...
Okay, so what the difference is on this, what it means, if it's a discrete domain, it means it can only be 1, 2, 3, 4, or 5 on this example, okay? If it is a continuous domain, it could be 1, it could be 1.2, 1.7, 2, 2.1, 2.2, 2.765. We don't know. It could be anywhere between 1 and 5. So continuous means you are not limited to whole numbers. Continuous means wherever it falls, anywhere in between there, it could be that. Does that kind of make sense?
So it could be like 2.1842012.8.
Or 4. Yeah. Any of those. So continuous just means anywhere in between. Discrete, you're limited to those exact numbers. That's the difference between the two. Okay? It'll make some sense once we kind of look at an example. This first part, we're going to look at graphing discrete data. So right now we're only talking about discrete. So it tells me the linear function y equals 15.95x represents the cost y in dollars of x tickets for a museum. Each customer can buy a maximum of 4 tickets. So first thing, we have that equation. So y'all go ahead and write that down. Y equals 15.95x. And they told me y represents the cost, x represents tickets. So what does this kind of represent so far? I mean, just kind of what does that mean when it says 15.95x? since we're talking about a museum? What is that going to tell me?
Continuous.
No, I'm not worried about discrete or continuous. Like, just generally, where did they get these? What does this equation mean, since we're talking about a museum? I know this is the cost, this is the number of tickets. So why do they have 15.95 times x? What does that tell me? Yeah, it tells me it's $15.95 per person to go to the museum. That's what that tells me.
It also says that each customer can only buy up to 4 tickets.
Okay, so then it says each customer can buy a maximum number of 4 tickets. Okay, so if we're looking at this, it says find the domain of the function. Is it discrete or continuous? So can you buy half of a ticket? No, you can only buy whole numbers of tickets. And they told us the max number we could buy was what?
4.
What's the minimum number?
1.
Do you have to buy one?
No.
So your minimum is 0. So is this discrete or continuous?
Discrete.
Discrete, because we can't buy half of a ticket.
You can't buy half a ticket.
Okay, so our domain is discrete. And we already said, what numbers would it be?
0, 1, 2, 3, and 4.
0, 1, 2, 3, 4. Because it said the max you could buy is 4. Well, you don't have to go. So the minimum would be 0 amount of tickets. So there's your domain. It's discrete, and it's 0, 1, 2, 3, 4.
Imagine paying for a ticket.
Then B says graph the function using its domain. So this is where we would create a table. We now have our domain. Domain is what values?
The domain
X
is
or Y?
X. And it goes left and
So if we were to make a table, we already have our X values. Right here would be your problem, your rule, and the answer you get out is your Y. We already have our numbers to plug in. 0, 1, 2, 3, and 4. Now we're just filling in our table. So here I have 15.95 times 0, which is just 0, which makes sense, right? If you buy 0 tickets, you should be paying $0.
Imagine paying for a ticket.
So then when we have one ticket would be $15.95. I should have made this one a little wider. So the rest of this is just having to plug and chug, plugging numbers in and solving. Excuse me. For sake of time, I'm just going to copy down the numbers. Gosh, I got stuck in my throat. So 2 would be 31.90. 3 is 47.85. And 4 tickets would be 63.80.
Why do they put a count of how many tickets you can buy?
Okay, so we would graph this. So when we're graphing, you have an X and a Y value. These are your points. You don't have to go back and write it, but I'm just showing you those are actual points. Okay, now it was discrete, correct? So these are individual points. We will not draw a line. So when we graph that, also, do we have any negative numbers on this? No, because you can't buy negative amount of tickets. So everything is positive. So you really only have to draw an L for your graph because we're not going to be in any of the negatives. We're only going to be in the positive. Since it goes all the way up to $63, I'm going to count by tens.
Imagine someone just goes to a museum just like, I will give me money and I'll give you my ticket.
But then I'll still count by ones over here.
That's like negatives.
So 0 tickets was $0. 1 ticket was $15.95. So obviously I cannot get exact, but you can basically tell that I'm at 15, which is close enough. So 2 tickets is $31.90. 3 tickets, $47.85. And 4 tickets, $63. Now, we're not drawing a straight line through it because it was discrete, so it's only those individual points. We can't have half of a ticket. But do you see that it is still linear?
Yeah.
Okay. Okay, example 5. Now we're going to look at graphing continuous data. So the one we just did was discrete. Now we're going to look at what it would look like if it were continuous. Okay, yes, it's going to make a straight line. We know that when we graph. But this says a cereal bar contains 130 calories. The number C of calories consumed is a function of the number B of bars eaten. Does this situation represent a linear function? Okay, so let's go back and read it. We know the cereal bar has 130 calories. The number of calories consumed depends on the number of bars you eat. Does that kind of sound like it's going to be proportional? Yeah. If I eat I almost said candy bars. If I eat 3 cereal bars, how would you figure out the total calories?
Add 130 plus or times 3.
Yeah, you just however many I'm going to eat times 130. So it's going to make a linear function because that's an equation. I could say C, calories consumed, will equal, what did y'all just tell me I do? We do 130 calories times, well, the number I eat.
B.
B for the number of bars that I eat. There is our equation. If you notice, we've got that y equals mx. Even though there's not a plus b, that just meant it was plus 0. It's in that form that tells me it's linear.
You might want to eat half a bar.
Yeah. Okay, so does it represent a linear function? Yes, and you could just say, yes, it's in y equals mx plus b form. That would be the answer to A. Okay, B says find the domain of the function. Is it discrete or continuous? Okay, so could we eat half of a cereal bar? Yeah. Nobody tells us that you can't eat just half of that. You have to eat the whole thing. So it would be continuous because I may take one bite and not want the rest. I can do that. If I want to eat the whole thing, I can. So we're not set on an exact amount of the cereal bar, that we have to eat. I guess I want candy. So it is continuous.
What is a cereal bar?
Okay, and then finding the domain. My mind just went, hold on. Can be any about, yeah. Okay, so can you eat less than 0 amount of candy bars?
Yes, yeah.
You can eat less than 0?
If you don't eat them.
Well, that would be 0. Can you eat less than that? No, you can't just throw up cereal you haven't eaten to do negative. So 0 is the minimum you can eat, right? You can't go less than that is what I was trying to say.
Why would you not want to eat water carbonated cereal?
Okay, so for our domain, it says you can eat part of a cereal bar. It can be any value greater than or equal to 0. So since it's continuous and we're set to a minimum of 0, your domain would just be, they said B for X, has to be greater than or equal to 0. Any other amount you can eat. Okay, so then C, graph the function using its domain. Now, since they tell me your domain is just B is greater than or equal to 0, you're going to have to come up with some values to plug into that table, starting with your smallest. So the first number we would have would be 0. So I'm just going to make it easy and go from there. 1, 2, 3. So we're still plugging numbers into a table just like we did a while ago. So my rule is 130B, or 130X. So we're plugging numbers in. 130 times 0, well, if you eat 0 cereal bars, you have consumed 0 calories.
Consume the nutrients.
What if that one song would taste the flavor, become the flavor or something? Well, that's
Skittles.
Oh, yeah,
Take
Skittles.
the rainbow.
And then we would graph that. Again, they're all positive. And it goes all the way up to 390. So I'm going to count by 50s. As long as you have a pattern on what you count by, you get to choose what you count by. I guess I kind of ran out of room. And then 1, 2, So 0, 0 was a point, 1, 130, 2, 260, and 3, 390. And since it was continuous, which meant you can fall anywhere, not exactly on those points, those are just the points we plotted, it is a straight line. Disregard my line, not touching anything. It should go through all of them. Okay, so that is, let me get where they can see that. So your graph should look similar to that. Mine's obviously not exact, so if yours is different, that's okay. So that is where we will stop.